Tom Campbell. It's my pleasure to be here today, having been part of the creation that was to become the Monroe Institute. I take particular pleasure in seeing how far it has come, how much it has grown, and how many lives it has enriched along the way. The theme of the 22nd professional seminar is Consciousness, the Endless Frontier. As one of the original explorers who has never stopped exploring, I am particularly pleased to have been asked to kick off this 22nd professional seminar. We're here because of our association with TMI and because of our interest in creative and useful applications of Hemi-Sync. So I will give you a short description of the genesis of both Hemi-Sync and TMI. Secondly, in consonance with the theme, Consciousness, the Endless Frontier, I will explain very quickly the core of what I have come to understand about the nature of consciousness and reality. Okay. Please hold your questions until the end. There's never enough time for questions, and I'm likely to take the lion's share of the 2 hours allotted to me, but I'm going to be here all day today, tomorrow, the next day, as long as most of you will be here, and I'm very open to have meetings. Whether it's early in the morning or late at night is fine with me, as long as it's fine with Shirley and it doesn't interrupt with any of the things that are already scheduled for the seminar. So I think we'll have to hold most of the questions until later today or the next several days. This is going to be a very quick skim over the top. Actually, it's more like a hop, skip, and a jump across the very top of this. Actually, this was a very hard presentation to generate. And not because I had a hard time figuring out what to say, but because I had a very hard time figuring out what not to say and still say within the 2-hour time limit. That was the challenge. Now, these slides are going to be busy. They're probably going to have more words on them than you can read. I'm going to go through them very quickly. I'm going to be speaking very quickly so that I can won't have Shirley mad at me for going over my time. I understand a big hook comes out from somewhere around here if you go past your time. So I'm motivated to get done. So it is going to be quick. All of these slides are going to be available on my website. You see that, www.mybigtoe.com. So you don't have to copy a lot of things down. You can find the slides. I haven't put up there yet, but I will just as soon as I get a chance to get on the internet. Also, the slides are on the computer here, so I'm sure TMI will pass them out to you if you have a thumb drive or some way to pick them up. So if the slides become a problem for you, trying to read them and listen, stop reading and just listen. Okay, I will say everything that you need to hear. You just let the slides go. They become annoying for you. Okay, first, a little introduction. Now and always a scientist sums it up pretty well. In college, I majored in both physics and mathematics, went on to grad school, finally did thesis work in experimental nuclear, and now I work for NASA. I do risk analysis, which basically means physics models, system behavior, complex system behavior. So the team that I work on, and it's a fairly large team, what we do is try to discover what could possibly go wrong, what the probability is of it going wrong, and then if it does go wrong, how do you fix it? Okay, well, how did a physicist like me end up, exploring consciousness and being part of the Explorer program early on? Well, once I left graduate school, I took a job, and my first boss, Bill Yost, introduced me to Bob Monroe's first book. Well, at that time, this is 1972, early in 72. At that time, it was his only book. And the boss comes out and he hands me the book and he says, "Tom, I want you to read this and tell me what you think." So I did. I read it, and a few weeks later, he asked me, "Well, what about this book?" And I said, "Well, there's 3 possibilities. 1, this guy has a good imagination and is just trying to sell books. 2, this guy's nuts. 3, this guy's sane, honest, and accurate, and there's a whole lot of reality out there that I would love to experience and understand. But how do you know? Unless you meet him and can get a measure of the man, how do you know? Is this guy nuts or what?" Well, my boss and I both kind of shrugged shoulders and agreed that it was just really impossible to know from reading the book. But evidently Bill was listening, And about 3 months later, he came by and said, "Hey, Tom, we've located Bob Monroe. He doesn't live that far away. There's a bunch of us going to go out and visit him. Would you like to come?" And I said, "Absolutely, I want to come. I want to know whether it's 1, 2, or 3. I want to meet this guy." Well, that was, like I say, that was more like the spring of '72. And toward the end of that meeting, we did meet with Bob, and we spent the whole evening with him. He was very gracious as usual. And I found out, of course, that it wasn't 1 or it wasn't 2, that Bob was very real. He was very genuine. He didn't have anything to sell. He just wanted to understand what was going on, and he wanted to put it into scientific terms so that he could share it with other people. That was his ambition. And we found out why it is he invited all of us and put up with us for a whole evening. Toward the end of the night, we were on the back deck of what was called the lab. There wasn't a whole lot in it at that point yet, but with Bob, it was one of those things like, build it and they will come. He had built it, and he wasn't quite sure, I don't think, what he was going to do with it at that point. But he looked at all of us, and he kind of scanned us over, and he said, "Well, you guys are all scientists and engineers, right?" And we all kind of looked at each other like, "What's coming next?" And we nodded our heads, yeah. And he says, "Well, would any of you like to join me here and work in this lab and help instrument it and put it together and study consciousness?" Well, it took me about a millisecond for my hand to go in the air. And I said, "Absolutely, I'd love to do that, Bob, but I'll do it if you teach me what you know." And he kind of considered that for about another half a second after that. Another hand went up in the air, and it was Dennis Mennerich. Now you have to understand, Dennis and I were both in our 20s. We were middle to late 20s at this time. And Dennis said, "I'd like to do it too, but I want you to teach me what you know." So Bob kind of looked around the rest of the group. I think he really was hoping somebody with a little more stature and experience and reputation, would take him up on it instead of 2 kids, not that far out of graduate school. But nobody else said anything at all, so it was a deal. And about 3 weeks later, Dennis and I are coming out to Whistlefield Farm. We're meeting with Bob, and from then on, we'd meet with Bob like Mondays, Wednesdays, and Fridays. We'd get there after dinner, about 7:30. We'd go to the lab, and we'd start building equipment. There really wasn't a whole lot there. There wasn't any measurement devices for the people. There was just audio into 3 booths. So we would build equipment and start figuring out what we were going to do next, experiments and things that we could do at the lab. After about an hour or so, Bob would come up, and then Dennis and I would get in the booths. There were 3 booths, and Bob would begin to carry out his part of the bargain, which is to teach us what it is. We knew there really wasn't a program then. I don't even know that Focus 10 existed then. It may have, but certainly nothing beyond that. So, Bob was just making it up as he went, and we were just making it up as we went, all trying to come up with something that would make science out of this. That was our goal. Well, we did this for years. Dennis and I were coming out here probably for pretty much straight 5 years or so. We were coming out 3 days a week, and we'd come out on weekends. So you can imagine that we were averaging somewhere between 20 and 30 hours a week, with the lab and with Bob. So, 20 hours a week with Bob Monroe as your personal trainer, you couldn't help but learn something, and learn something pretty quickly. So it wasn't that long before Dennis and I had pretty well mastered the altered states. We were going out of body. We were making non-physical friends and people that we could get information from. We were doing experiments. Everything had to be experimental. There wasn't any point in doing anything you couldn't check to see whether it was real or not. So that was the kind of the ground rule. It wasn't just fun and games and have a neat experience. It was, is this real? And it took a while before, it probably took a year and a half or so before I got to the point that I could answer that question with a yes. And that's, everyone has to come to that point somewhere where you decide, is this real or am I making this up? But in any case, Dennis and I were in the cut and try mode, and we were doing anything that we could. We ourselves had become very sensitive instruments to altered states of consciousness. Bob drilled us going, down to that pulsation state, out of body and back up and back down and so on. We did that thousands of times, so we'd be very sensitive to the altered states and the pathway in between them. That was the first part of our training. So Dennis and I were very sensitive to our consciousness and what state it was in at that time. So we'd do things, we crawled in pyramids, aluminum pyramids because a book was out that said, inside a pyramid oriented with the, you could get different, altered states. Everything that was ever published, we tried to read on the subject. So we'd go into pyramids and see what it did to us because we were very sensitive. I stuck my head between two big capacitor plates with a couple 100,000 volts on them to see whether or not we could oscillate the pineal gland, because we had read back in the Muldoon and Carrington days that they thought it had to do with the pineal gland, and we thought, well, and we knew it had to do with 4 hertz because Bob, and we did too, when we got in that pulsation state, you'd get this around 4 hertz vibration going on. So we knew that was physical, because once we outfitted the lab with GSR, we could actually see that little GSR meter sit there and oscillate at 4 hertz. So it wasn't just a perception of consciousness. There was something physiological going on that was oscillating at 4 hertz. So those were our only keys. So we were cutting and trying everything. Dennis went to visit some faith healers from the Dominican Republic and see what he did. And each time we were using our body as the instrument and our mind as the instrument of how did it affect our consciousness, looking for tools. Okay, well that went on for a year or so, and we were unsuccessful in finding appropriate tools. And one day while I was at work, and Dennis and I worked at the same place, Dennis came by, he gave me some papers and said, take a look at this, maybe we can use it out at the lab. So I looked at it, and it was an article by Oster about binaural beats. And in that article, it mentioned that it was thought that binaural beats might entrain EEG, might entrain brainwaves. So that sounded pretty interesting. So we thought, yeah, well, let's give it a try. I mean, we were trying everything. And unfortunately, the very few days after that, Dennis had to leave the country with his job, took him out of the country for about a month. And when he came back, he went to the double E lab. He was a double E, and went to the double E lab at University of Virginia, borrowed some equipment, made a binaural beat tape. It was a very nicely done tape. He started out at alpha and went down, or started out at alpha, stepped down, small steps at a time, down to the theta region at the 4 hertz, stayed there for an hour or two and stepped back up. And we vowed we'd go out to the lab our first opportunity. Well, it was good timing, actually. Bob was out of town. He was out of town for 2 weeks, so that gave us lots of time to play in the lab. And because we would rather be in the bed being instructed by Bob than we would be actually doing research on our own. So this gave us time to play around, and we went out, we put that binaural beat tape on, and we listened to it, and there it just stepped us down. We followed it. We didn't try to do anything with it, just listen. And we could tell from our consciousness, it would just drop us, and we could tell when that would go down 1 hertz, it would drop. We could feel every step of the way. It was like walking down a pair of steps. Then it put us in that theta state, held us there without any effort on our part, and stepped us right back up again. And we both got out of those beds and looked at each other and said, wow, that really worked for me. Did it work for you? And we agreed that it did. And we were very excited about that. And for the next week and a half, while Bob was gone, what we did was try to optimize it. We tried different bass frequencies. We tried different waveforms. Besides the sine wave, we put in triangular waves and square waves and all kinds of other things. We tried different volumes and intensities. And so by the time Bob came back, we had what we thought was a pretty good sound, and it was very effective. We told Bob about it, and actually Bob, I think, was even more excited than we were. Because he had the bigger picture. I mean, we were just young guys in a lab, and he kind of saw where maybe this would go. So the next step was to determine whether or not it was just us. We weren't exactly normal anymore. We'd been doing this with Bob for a year and a half, and we were very sensitive, and our consciousness, we knew how to get down and get in that theta state and get out of body and that sort of thing very routinely. So we weren't just the average person, but we had to know, would it affect the average person, or was it just us because of all the training we had had? So the next thing was to get people in there who were naive subjects, if you will. And Dennis and I brought our wives, and we brought our children, and we brought our friends and neighbors and anyone we could, and we didn't tell them anything. We just said, listen to this, and then describe what happens, what happens with your mind. Just listen to it. And Bob was doing the same thing. Everybody that passed through Whistlefield, and in those days, people were constantly passing through Whistlefield. Bob was like a hub of interest in the larger reality, and he would snatch all of them, get them up to the lab, and have them, listen to this and see what you think. Well, after a couple of months of trying this on naive subjects, we found that it affected everyone. Now, everyone didn't go out of body. It depends a whole lot on what you bring to it. Some people, as soon as you'd get down to that theta level, they would just lose consciousness, just snap, they were gone. And as soon as they stepped back out of it, snap, they were awake again. And they'd say, oh, I fell asleep. Well, they didn't really fall asleep. They weren't tired. You know, they just lost consciousness. But it did affect everybody. So we knew we had something to pursue. And what we needed then was a real experiment, some people that we could run through the paces, naive subjects again. So Bob called up some of his friends and passed the word around that he had a technology that was effective in helping one go out of body. And he got overwhelmed with responses. He booked the Tuckahoe Motel, which is a little motel over on Route 250. At that time, it had already seen its heyday and was a little bit dilapidated, run down, little motel. I think it had maybe 20 units, just one rectangular building with 10 doors on either side. And he booked the whole motel. And we had then about 2 or 3 weeks to get ready for 20 people that we were going to be our lab rats, and we were going to run them through a program. Now, Bob wanted to know, what could this do? Where did this putting them in this state, what did it allow them to do? So his job was to produce the program. And he produced a program that had them looking in envelopes, reading numbers, seeing pictures, remote viewing. We had targets laid out. They were healing. They were visiting relatives. They were doing just anything you could imagine, that he could think of. We just wanted to know what happened. These are people that probably had been doing some of this stuff anyway, but what difference would it make now that they were listening to the sound? So we had this seminar, and by that time, Nancy Lee had joined us. And Nancy Lee had come in probably about the last month or so of that. She just graduated from college. And she was the organizer. She organized this whole thing, got people's travel arrangements, picked them up at the airport, got all the logistics, the refreshments, everything. So she was the organizer. Bob was busy doing the program, and Dennis and Bill Yost and I were in Bill Yost's garage trying to build equipment so we could put sound for 2 people in 20 rooms and GSR on all of them, so we could keep track of what it was going on with their bodies. And that was a rush. As the people started arriving, Dennis and I were still in the closets of the motel rooms, soldering wires. Nancy Lee was in a Twitter because, everything, of course, at the last minute happens all at the same time, and she was organizing it all. And Bob was probably the only one that, was serene, but he was putting the final touches on his program. Well, the people came, they got in their beds, they put on their headphones, and for 2 days, for the weekend, it was the most paranormal things that I'd ever seen happen, at one time. One of the things you had them do was shining their energy beams, light up in the sky, and we'd go outside and see if we could see the lights in the sky, and there were lights in the sky, and there were more paranormal experiences. There were, these people got out of body, they made contacts, they read things in the envelopes, they saw the pictures, and we had some very good hits that way. So it was just a phenomenal weekend. And about that time, I think Bob started to think, I think we've got something. And there's enough interest that perhaps we can develop this and it'll even pay for itself. Up to that time, Bob paid for everything. He built the lab. He paid for the equipment. He paid for the components that we put together. So it was all out of his pocket up to that point. And I think he was looking for a way to expand that so more people could get involved. So then we held a few more of these seminars at the Tuckahoe since we had that building wired. And we decided to make use of it. And there were 3 or 4 more held there. And matter of fact, the next speaker, the first speaker this afternoon, Joseph Pierce, he came to one of those additional seminars. So you'll have somebody here that was there at the Tuckahoe. I remember Joe because the way it worked is that Bob would come right in the morning, and he'd say hello to everybody and give them a little pep talk. Then he would leave it, and Dennis and Nancy Lee and I would run the program, and Bob would show back up at the end, just when everybody was done, and say, well, how'd everybody do, and talk, and have a little thing at the end. So I remember Joe very well. I think Joe was a little disappointed that he had to deal with a couple of 20-something-year-olds, and not Bob Monroe for the whole weekend. But In any case, that's the way it was run. Well, we found out pretty soon that 20 rooms wasn't enough. And then I put Dennis and Bill Yost and I back in the garage, building now a portable audio harness that could play to 30, I think, maybe 40 people. We started renting large conference rooms in hotels, taking all the furniture out. The hotel people wondered, what were we doing? The table went out, the chairs went out, everything, and we would have, it'd be a room like this room, and we'd have aisles, and then we'd have bodies laid out all over the floor. You know, and every 2 or 3 feet there'd be another body laying out on the floor, and they all had to come with their own mats, and or if they didn't have a mat, they just laid on the floor. And we put this wiring harness down the middle of the aisles and peeled off the earphones and so on to everybody. And again, you know, it was Dennis and Nancy Lee and Tom that ran the seminars, and Bob would come in at the beginning and he'd come in at the end. So we did this and ran a bunch of those. At that time, the demand kept growing. Pretty soon, it was we needed a way to do this off-site, not just here in the Charlottesville area, but off-site. Now, this new land hadn't happened yet. We weren't here where we are today. We were still at Whistlefield Farm, was the headquarters of all of this, and so we started to go on the road. We'd pack up that harness, and Nancy Lee and I would go off to California and do a seminar, and Nancy Lee and Dennis would go off to the Northeast and do a seminar, and so it went until Dennis and I, with full-time jobs and full-time families, you know, and now being trainers besides on the road, was just more than we could stand. So at that point, Dennis and I started to kind of back out and look for replacements. And Bob took a little chance to kind of stop and rest and see what he was going to do next with it, because it was obvious he had something that was going to work. So shortly after then that Bob purchased this new land, a place where he could build a facility. And other people came in. Dennis and I kind of slipped out the back. Now, I was still on the board and still interfaced a little bit here, but then that was kind of the end of my tenure with it. But so that was the invention, if you will, of Hemi-Sync and of TMI. Those things came later. Bob patented that binaural-beat sound as Hemi-Sync, and that was his name that he chose for it. And eventually, of course, the organization got changed a couple of times until finally it ended up as TMI over here on the new land. Okay, so that's it for the history lesson. That's where Hemi-Sync and TMI came from. Now let's do a little physics and a little metaphysics, and I'll try to give you a quick rundown about what the nature of reality looks like. Okay, and I'm very likely to break some of your favorite paradigms. Well, we're one ahead, but that's all right. I'll get there. Very, very likely to break some of your paradigms. I'm very likely to run over a few of your most cherished cultural, personal, scientific beliefs. But instead of believing or disbelieving what I say, just consider the possibilities and assess the probability based on your own experience. Use open-minded skepticism until you find out. You must develop your own personal big picture from your own personal experience. Until it's your personal experience, it cannot be your truth. Okay, so always remain both open-minded and skeptical. If you are not open-minded, you'll never learn anything new. If you're not skeptical, you'll never know whether what you're experiencing is real or made up. Okay, so you must be both. Okay, now we're going to look at some big picture models. Big picture model has to describe everything, objective and subjective, physics and metaphysics, the normal and the paranormal. Today I'm going to explain big picture science, and I will show you that the big picture science derives little picture science as well as metaphysics. Okay, to be valuable, big picture science must provide a superset, must provide better, more complete physics and better, more complete metaphysics. First, a historical perspective. Albert Einstein, the last 25 years of his career, he worked on a thing called unified field theory. This was going to be a TOE. TOE means theory of everything. And what that means was one understanding, one set of principles in which he could derive all of science, just from one principles. And really what he was interested in, he wanted one set of principles that could derive both quantum mechanics and relativity. Those were the two big new things in science, and they didn't look like they went together. They were kind of separate things off doing their own thing, and he knew there must have been something more general understanding from which you could derive both, and that's what he wanted. And that actually boiled down to just finding out two things. One, why was the velocity of light a constant? Because that's the key to developing relativity. Once you understand that light's constant, relativity just falls out with a little algebra. Okay, and the second was, why should particles really not be particles, but be probability distributions? Because once you understand that, then quantum mechanics falls out very naturally with a little algebra. So those were his issues. Now I'm going to do some quotes to let you know where Albert Einstein ended up. After 25 years of studying the larger reality from his view, what were his conclusions? Okay, space does not have an independent existence. It's a quote from Albert Einstein. Reality is merely an illusion. Okay, hence it's clear that in the space of physics, is not, in the last analysis, anything given in nature or independent of human thought. It's a function of our conceptual scheme. Space, which is our reality, is a function of mind. Now, this is Albert Einstein. This isn't some New Age guy, with long hair on the street corner. Well, he had long hair, but still wasn't a New Age guy. This was Albert Einstein, probably one of the most competent and far-reaching scientists who knew how to think out of the box. And these were his conclusions. Okay. Now, David Bohm, another physicist, very highly respected, worked with Albert Einstein. So, he had to be highly respected to work with the best of the best. The thing he said was, our notions of consciousness must have room in them to understand what it means for its content to be reality as a whole. Okay? Consciousness has to contain reality as a whole. Again, these are physicists, very, the top of the top. They had a problem. They knew that consciousness was at the root. That was fundamental. But they just didn't know what to do about it. They were stuck. All right, we know that. Now what? Well, here's a letter from Einstein to Bohm, written on October 28, 1954. One has to find a possibility to avoid the continuum together with space and time altogether. But I have not the slightest idea what kind of elementary concepts could be used in such a theory. See, they were just stuck. Now, coming from a different direction, quantum mechanics produced an even stranger view of reality. Okay, and I'm going to run through why quantum mechanics came to be. Quantum mechanics existed because of this experiment. It's a very famous experiment, and it's called the double slit experiment. For many years, scientists knew that if you put light through two slits in a barrier, that you would get this diffraction pattern. What would happen is some of the light would go through this slit, some of the light would go through this slit, and then the light would interfere with each other. The way it interfered is that the distance between here and that point and the distance between here and that point from the two slits had to be some integral number of wavelengths so that the wavelengths got there in phase. And when they did, you'd get some light. And when they didn't, when they got out of phase, you got nothing. You got dark spots in between them. Okay, so this was an experiment, well known, done many times, diffraction grating. And then Einstein came along and studied the thermoelectric light hitting things and knocking out electrons, okay? Yeah, photoelectric effect. He was studying that, and he realized that light looked like a particle. It seemed to always have some integer number of chunks of momentum. It came with little chunks of momentum, just like particles. So he said, light's a particle, and his theory supported that. Well, now that made a big question. Well, if light's a particle, particles we know, they go through slits. They just travel in straight lines unless interacted on by an exterior force, right? Newton told us that. And they would put a little spot of light behind that slit and a little spot of light right behind that spot. That's what a particle would do. So if light's particles, how do we get this? So they decided, let's test this out. They were very clever, found a way to fire one photon at a time at these slits. So they fired a photon. Of course, one photon isn't enough to measure, particularly in those days. So they actually fired thousands, but they only fired them one at a time. So only one photon at a time interacted with these slits. And what do you think they got? Did they get this or this? Well, they got this. They got a diffraction pattern. Now, how was that? You were sending particles in these slits, and you got this diffraction pattern. Well, they didn't understand that very well. So they said, well, let's look and see what's going on at those slits. So these little red things are symbolizing detectors. So they put photon detectors there and said, let's see what's happening at the slit. And when they did, sure enough, they occasionally, when the photon got fired, they'd find that it would go through this slit, and when it did, they'd get a little thing from their detector. And when it did, it'd go straight through, just like Newton said, and stop right at the back behind the slit. And when one went through this slit, it would stop right there, and they got this pattern. So then it was thinking, well, it's the detectors are making the difference. When we detect it, we get this, and we don't detect it, we get this. So whether it was by just luck or whether it's because they were clever, I don't know. But fortunately, one of them decided to leave the detectors on, because if they turned off the detectors entirely, of course, they got this. And the idea was, well, the detectors are interfering. So somebody decided to leave the detectors on, but just not take any data. In other words, the detectors were there detecting, but they just weren't collecting any data. So if it was, let's say, going to a magnetic tape, then there was no magnetic tape loaded. Okay, the head of the tape was still showing what the detector said. The head of the tape was still oscillating because the detectors were working. The detectors were still detecting. Well, what do you think happened? They got this. They got the diffraction pattern. Okay, so what it turned out was that if they looked, if they collected the data, okay, then they get this. If they didn't collect the data and they weren't looking, they got this. That let them know that it was the actual conscious act of taking the data that made the difference as to whether light was a wave or light was a particle. Well, that was a really big deal. Okay, suddenly, you know, life wasn't clear anymore. It had been real clear up to that time, and it wasn't clear. Okay, go to the next one. Here's how that works. A bright young guy named Erwin Schrödinger, German. He was a graduate student, and if you'll notice in physics, most of the big breakthroughs occur with young people because they haven't been in the system long enough to understand what's impossible. So they're still open-minded. They can still think out of the box because they haven't gotten educated enough not to be able to do that. So what he said is, well, look, these things come through here one at a time. The photon obviously can't break up into pieces. You know, a photon's a photon. So it must be going through here, and some of the time it goes up here, which was a smaller spot. Some of the time it goes, each one of those photons must somehow pick a place to go, but it always picks one of these spots and never picks the spaces in between. So what he would do is, he said, well, let's say that this photon's really not a photon at all. It's just probability distribution. Now, by that, I don't mean that the photon is somewhere and we just don't know where, and that's the probability of where it is. I mean that the photon doesn't exist as a particle. It's a probability distribution. So given that it's a probability distribution, some of the probability goes through that hole, some of the probability goes through that hole. In other words, the probability is that some of it could go here. There's a certain amount of probability that goes here. The probability then interferes with itself like a wave, and you get this pattern. Well, when he did that with the math, of course, it worked, and he got the pattern, and the physicists of the day looked at it and shook their heads, the graduate students, you know, I mean, okay, you got the answer, but it doesn't make any sense. Well, then they took his methodology and they applied it to other things at the day, and guess what? It got the right answers there too. And it kept getting right answers. So physicists had to take it seriously, even though it didn't make any sense. Quantum mechanics now is one of the most successful branches of physics ever, and it still doesn't make any sense, you see? To physicists, they still don't understand it, but you're going to understand it by the end of this day. You know, you will understand it, and you'll have that much up on physicists. So that's it. These particles are just probability distributions. Now, here's the way it was. Here's the way that was described. At this point, do we have another one of those slides? Okay. At this point, they realized that it's because they took the measurement, right? Consciousness is involved. They said that the probability wave function collapses to a physical particle when the measurement is made. Okay? The measurement collapses the wave form to a physical particle. So because they made the measurement here, they got a physical particle there. And when you have a physical particle, just like Newton says, it travels in a straight line until it hits something. Here, the measurement was made here. So they didn't have a physical particle until the measurement was made. And when the measurement wave was made here, you got this diffraction pattern, because up until this point, there was no particle. It was just probability. You see? So that was the answer. That's still the answer. All right? Now, I'll give you a couple of quotes from some of the, we'll go one more slide there. To people who helped develop quantum mechanics. First is from Eugene Wigner. And he was a Nobel Prize winner. He was one of the leading scientists that worked on the original quantum mechanics. He says, "It will remain remarkable in whatever way our future concepts may develop that the very study of the external world led to the scientific conclusion that the content of the consciousness is the ultimate universal reality." Again, these are not New Agers, right? New Age hadn't happened yet. This is back in the early 1900s, 1950, 1920, 1925, that kind of time span. These are top-notch physicists. Max Planck, often known as the father of quantum mechanics, he didn't invent it, but he did a lot of work in it. And science cannot solve the ultimate mystery of nature, because in the last analysis, we ourselves are part of the mystery we're trying to solve. And that sounds just like Einstein. The last quote, it said, "The space of physics is a function of our conceptual scheme." In other words, what's out here, our reality, is entangled with what's in here. Okay? So the summary of that is, 1, reality is a product of consciousness. 2, reality, mass, particles exist only as probability until a measurement is made. 2 fundamental truths that we knew back in the early 1900s. Now, we don't even seem to know that now, right? Science would probably read those 2 things and say, nah, that's not possible. Well, what happened? How come we kind of dumbed down over the last 100 years? Well, it's because, like in any field, when you hit the wall where you just can't take the next step, just like Einstein did, I have no idea, what elementary concepts to use next. Well, you avoid it, because that's a career breaker, not a career builder. You go work where you can make something happen, where you can, write papers and get funding. So this whole concept was just kind of walked away from because nobody knew what to do with it. It was a dead end, just like Einstein got dead-ended. Okay, now let's bump up to the present time. We're going to get contemporary now. Edward Fredkin started in 1992 a digital physics movement. Edward Fredkin is still a major physicist, one of the big guns, if you will, in physics still today. He's still a working scientist, highly respected. He came to the conclusion from his science, and very well done science at that. He presented this at a physics forum, that we must be living in a computer simulation, that our reality is digital, it's basically information, and we're computed. Okay? Now, it takes a brave man to stand up and say that in a physics colloquium in 1992, but he wasn't saying this because he saw it in a dream, or he felt like it was a neat idea. He had science that led to that conclusion. Okay? That was a scientific fact in his mind. Well, of course, if you tell people that we're living in a computer simulation, the first question is, where's the computer and who's programmed it? Well, he said his science didn't tell him anything about that. So he just called it other. He said the computer is in other, quote unquote. And that he had no idea where other was, but he did know that the rest of this was a fact, whether he knew about other or not. So then we have Nick Bostrom. He's now head of a department at Oxford. Okay? So again, no person of light reputation. He worked in Ivy League school here in the States. He has advanced degrees in both philosophy and in physics. And he wrote a paper called "Are You Living in a Computer Simulation?" And the bottom line is, he said, it's very probable that we are all living in a computer simulation. Okay, now the last guy, he's not a physicist. He's actually a mathematician. He works at the Center for Discrete Mathematics and Theoretical Computing. And this had been around now, you see, for a decade. 92 had been around for about a decade, and this came, I guess, about 10 years later, and then this came about 10 years after that. So we're leaping decades here. And this digital physics caught on. There are digital physicists now all over the world. Digital physics is a solid branch of physics, still out on the fringe, but breakthroughs only come from the fringe. Breakthroughs never come from the center. That's not the center's purpose. The center's purpose is stability and infrastructure, not creative thinking. The creative thinking always comes out on a fringe. So in any case, Brian looked at this because the digital physicist said reality is virtual, it's computed. And the fundamental theory of physics says reality is because it is. You know, it starts with a Big Bang, and the Big Bang has no cause. It's a causal thing. You know, there is no cause for the Big Bang. Physics just starts with a Big Bang without a cause. It happens, you have all this energy, it's very tightly packed, then it expands, and it cools, and you get planets coalesce and suns and so on. But there is no cause for a Big Bang. So, you know, that's a mystical assumption, something without a cause. So physics is really, the fundamental traditional physics is really based upon a mystical assumption that something happens out of nothing, which is the Big Bang. So our universe is kind of popped out of nothing. Well, Brian took these two ideas, the traditional physics that we just exist because we do and everything's here because it is, and the one that this is a computed virtual reality. He had this big matrix, and down one side was all the things we knew, all the facts. What did we know by experiment? Okay, that's the data. Those are the data points. And then he took the virtual reality idea and said, how does that fit the data? How does that explain the data? And then he took the traditional physics, how does that fit the data? So he had this big matrix, and when he was done, the last paragraph in his paper said, physicists, wake up. This concept of a virtual reality fits the data a whole lot better than the traditional concept. It explains more with fewer problems. So that was a paper just presented like a year and a half ago, and since then Whitworth has presented another paper that takes this idea on a little further. So that's where we are present day. Now let's leave physics for a bit and talk about metaphysics and reality and see how all this ties together. Okay, reality is information. Now that may be a little hard for you to swallow, but reality is information. But now look at it this way. What is your reality? What's your reality right now? Well, it comes through your senses, right? It's just what you see, hear, feel, smell. That's your reality. If you didn't have any senses, what would your reality be? Nothing. You'd be a point of consciousness floating in a black void. That's all. Okay? So what is this reality? It's just data. That's all. Photons hit your eyes, get focused by the lens, go to the retina, and what happens at the retina? They turn into electrical pulses, discrete electrical pulses, not continuous electrical, discrete pulses. Those pulses go into your nervous system, and what do they turn into? They hit synapses, and neurons fire off in different directions. You get neurons and patterns of neurons. What are neurons? Discrete pieces of information. So what is your reality? It's data. It's little electrical blips. It's neurons and patterns of neurons. It's digital data. And when I say digital, I mean discrete. Digital is another word for discrete. It comes in packets, little separate units, neurons, little pulses. So that's what your reality is. Nothing but data. Now, if all of your senses were somehow terminated and you were in that black void of point consciousness, and then I could stimulate your central nervous system just like it's being stimulated now. I could reproduce all those little electrical signals just at the right places in your central nervous system. What would you experience? You'd experience just what you're experiencing now. And there'd be no way for you to tell the difference. No experiment that you could do that would differentiate one from the other. So now it's just a small step from there to say, well, what is our reality? It's just a data stream. It's a data stream coming down to consciousness, and we interpret that data as this reality. Because in fact, that's what's happening here. We're getting the photons, we're getting the pressure waves on our ears. It turns into data, and our brain, we think it's our brain, it's not really our brain, it's our consciousness, interprets that data to be this reality. This is just an interpretation of a lot of digital information. That's what this is. That's what all this reality is. Okay, so consciousness is the fundamental reality. The larger consciousness system is a digital information system. At the most fundamental level, consciousness is just information. Information at the most fundamental level is bits. I'm not going to, we can get more complicated than bits and binary. We could go qubits, and there's other things besides binary, but I'm just keeping it at the most basic level here to get the concepts across. The most basic level information is bits, and the most basic level bits are binary. Okay? That's the most basic thing. So information is non-physical and subjective. Thus, consciousness is non-physical and subjective. And you're thinking, information is non-physical? oh, wait a minute, this is the information age, and I have information overload, and why is it non-physical? It'd be easy to get rid of if it were non-physical. But think about it, it is. Information is the meaning, the content, the message. It's not the media. Okay, that's the paper in the book is the media. It's not the code symbols. That's the ink squiggles on the book. Those are the code symbols. Neither one of those are information. It's not until a consciousness looks at those code symbols on that paper that it extracts the information. Information requires consciousness. Now, you can put a book, you can put paper in a bottle. You can put ink in a bottle, but you can't put information in a bottle. The content, the meaning, is non-physical. That can't be weighed, has no weight, takes up no space. It's not physical. Okay, so information's non-physical. If consciousness is just an information field, then consciousness is non-physical. Okay, we've done that. Okay, that takes us to information in a digital system is represented by organized bits. So let's talk about organization. If you were a double E, you'd say this in terms of signal and noise. You have a signal, that's the information, and you have noise, and that's still energy, but it's random. There's no information in randomness. So to get information, you have to not have randomness. You have to have order. Okay, now a measure of order, or perhaps I should say a measure of disorder, is called entropy. It's a measure of disorder. So if you have high entropy, you have a lot of disorder, you have randomness. If you have low entropy, you have a lot of order, a lot of coherency. Okay, that's the difference. So if you have an information system, this information system is, as it has information in it, it has to have order. As that information dissipates and no longer has information, you go to higher entropy. All right. Entropy can be thought of in another way as well, and you'll see how the two are connected. If you have high entropy, you have very little ability to affect anything or do anything. If you have low entropy, you have a lot of ability to affect things. You have power. The physics term is it's the ability to do work, but you have power. Now, imagine a bottle of gasoline. So you have a bottle of gasoline. As a bottle of gasoline, the molecules in that gasoline, that'll be our system, they have a lot of ability to do things, right? They can change things. You can throw a match in there and suddenly everything in the vicinity is changed. You can pour it in your car and you can drive your car someplace. So that gasoline, because those molecules of gasoline are ordered, they're packed in a very small place. It's so dense it's a liquid. Okay, now we let that same gasoline evaporate. Now they've evaporated, entirely gone. We still have a system of gasoline, still same number of gasoline molecules exist in the universe. They're just spread all over the atmosphere. What can they do? Nothing. See, they've lost their power because they've lost their order. Now they're random and they lose power. So that's two ideas about entropy. It's a measure of disorder, and it also tells you it's a measure of power or ability to affect something. All right. Self-changing systems with a purpose evolved to be more successful within their environments by lowering their entropy. Evolution is a very fundamental concept. Technologies evolve. Governments, monetary systems, everything evolves or de-evolves. It goes both ways. But things change. Self-changing systems that can learn and that can change themselves evolve. And you can take that evolution and explain it in terms of entropy. You evolve when you're decreasing the entropy of your system. In other words, the system works better. It's more organized. It's more functional. And you're de-evolving as you dissipate that information, and it becomes more random. Okay, so even our own evolution our biological evolution can be put in that term, in terms of entropy. So consciousness is a self-aware, self-modifying system evolving toward lower entropy states. All right, let's talk about the attributes of consciousness. Well, one more thing about evolution, and that is that a large complex system only has two choices. You'd think it might have three. It can either evolve, it can de-evolve, or it can stay the same. Well, in any large complex system, staying the same is not a stable option. Okay, you might think that, well, it could gain a little, lose a little, gain a little, and kind of stay constant, we want an average, but that doesn't happen. That's short-term stable, but not long-term stable. Large systems that can change will either eventually evolve or de-evolve. So it's your choice there, if you're one of those systems, is to evolve or die. That's the choice, which means you decrease entropy or die. Okay, individual consciousness evolves toward lower states of entropy, and that's equivalent to saying higher quality consciousness or more spiritual states. So then we'll take one step from that and say that love is a description of a low entropy consciousness. That's what love is. Love is a low entropy consciousness. Okay, now you can think about that. That makes sense. Love is cooperative. It's about other. It's about caring. That builds, constructs, watches out for each other. You can see that as kind of a building, constructing thing, where on the other side you have fear, you have hysteria, you have anxiety, you have all of that sort of thing. And instead of being about other, it's about self. It's all about me and mine, as opposed to building anything constructive. It's about me making sure I get hold of mine. That tends to pull things apart. That's not cohesive and doesn't build. So you can see that love is the direction of evolution in consciousness. You lower the entropy of consciousness, you're moving toward love. Okay, attributes of consciousness. Input, that's experience. Memory, if you didn't have memory, every input would be the first. Processing, you have to be able to look at that experience that you get from input and assess it. Purpose, that's how you assess it. You assess it against a purpose. And you have to be self-modifying. Okay, those are the basic attributes. Now think about these attributes. They describe exactly our biological systems as well. Think of those biological cells. Say when the cells, the first cell, if you like, or maybe the first little groups of multi-celled creatures that are in the primordial sea someplace, what did they have to have? They had to have connection to their environment, right? They had to interact with their environment. That's the input. They had to have memory. Now, it wasn't intellectual memory. It was just cellular memory. But they had to have memory. Otherwise, they'd never know, where they'd been, whether things were better or not. They had to have purpose. That was to procreate and survive. That was their purpose, which means lower their entropy. And they had to be self-modifying. If they weren't self-modifying, well, we wouldn't be here, right? They'd still be just those few little cells. They had to be able to change themselves against their purpose, survive and multiply, against the data, which was coming from the environment, against their input. Okay? So as it turns out, this input, memory, processing, purpose, and self-modifying is a description of consciousness. It's also a description of life. That describes, those are the qualifications for sentience. Okay? Anything that's sentient, anything that can react and interact, okay, has to have these things. Well, what else does that remind you of? Input, memory, processing. Sounds kind of like your desktop computer, doesn't it? Till we get down to the last two, with purpose and self-modifying. But someday those two will be overcome as well. We will one day probably see conscious computers. Anyway, drop that bomb and just move on. We'll talk about that. We'll talk about that later if you like. All right, let's do it. Let's do a summary. Summary. Consciousness is best modeled as a superset. Got the summary? Good. A self-modifying digital information system capable of computing virtual realities. The larger conscious system evolves by lowering the entropy of the system. It lowers the entropy of the system by organizing bits at its disposal to more profitable configuration. I'm just summarizing all the things we just said. Feedback of the results of previous choice allows us to modify future choice. That's free will. Next, let's find out where we come from. Okay, what are we here? Consciousness. Because experience, okay, is the generator of input. In order to have the experience, you need interaction with something. Experience comes from interaction. Well, if you have one monolithic consciousness, the only thing it can interact with, the only thing it can have experience with is itself. That's extremely limiting. So just like those biological cells that decided to split and start to evolve multi-celled things, which were lower entropy, more order, right? More construction, more things working for the whole. Same with consciousness. Consciousness divides itself into pieces so those pieces can interact with each other with free will. Now you have, let's say, thousands of smaller things all interacting with free will. Suddenly your ability to have novelty and to have experience that you can grow from, that you can lower your entropy from, is much, much greater. Much more experience instead of just one thing interacting with itself. Okay, so that's what we are. We're those chunks of consciousness. We're one of those chunks of consciousness. And now you see that we, just our existence, what we're here for is to lower our entropy, evolve toward love, right? That tells you your purpose. And we're also, it tells you that we are part of the system, but the system now is the larger consciousness system. We're part of that system's way of evolving, right? It's strategy to evolve. Okay, so as we evolve and lower our entropy, the whole system lowers its entropy, because any part of the system lowers its entropy by a smidgen. The whole system has its entropy lowered by that smidgen. So we're part of the strategy of the larger system. It's evolution. All right, that tells you our purpose, positive direction of that purpose. That defines what's negative, what's positive, what's good, what's bad, what's moral and immoral. Okay? What's positive and good and moral are all those things that lead to decreasing the energy, moving toward love. What's negative, bad, and immoral are all those things that do the opposite, that increase the entropy of your personal consciousness. It breaks out real easily like that, and a logical breakout of that's done in my forum. There's a thing in there that's a moral code that kind of lays all that out, and how that works. We don't have time for that now. That would be more than 2 hours just by itself. Okay, now we've got us. Then what about physical reality? Where does physical reality come from? Well, to produce an effective, profitable interaction, you need two things. You need a goal. Well, we've got a goal, lower the entropy. But you also need constraints. Why do you need constraints? Constraints give us strategy, logic, order, feedback, learning. You can't learn without constraints. Think of a kindergarten class with no constraints. What would they learn? They'd learn to be wild, right? Anarchists is what they'd learn. Okay, you need constraints to learn. Think of a game. Let's say you're a player with 4 people sitting down playing cards, and there are no rules. Okay, what's your strategy? How do you learn? How do you know who's winning? You can't. Without constraints, without rules, it's impossible. You can't get any traction on it. Without rules, basically all you have is chaos. Evolution is difficult or impossible. Okay, so now this reality then is an elementary school. This is our schoolhouse. It has rules. What's the rules? Physics. That's what scientists do. Our rules are our science. Science goes out and tries to discover what the rules are. Okay, so the rule sets are physics. All right. Now, in order for a virtual reality like our physical reality to be effective, okay, consciousness must be able to roughly predict what's going to happen next. And I'll see you, I can show you later why that's so. Okay, that information is important because it provides feedback, and it's important to render this reality. Is used as a tool. So the consciousness has some rough idea what's going to happen next. We have free will, so nobody can really know what's going to happen next because we can do things that are unexpected. But because we're in a virtual reality, then how do virtual realities work? They all work the same way. Now, you've probably bumped up against virtual realities before, at least if you know any kids you have. My son played World of Warcraft, so I know about World of Warcraft because he was constantly at the computer when he should have been doing his homework. My daughter played The Sims. Both of those are virtual reality games, multiplayer virtual reality games that you've either played or you probably know somebody that's played them. Well, they all work the same way. We are a virtual reality who then creates other virtual reality games, you see. The way virtual reality works, the way any dynamic simulation works, is you have the simulation and then you step it by time. So time, let's say we start right now and the time is something. Well, then you increase that time by a delta t, just a little bit more, and then you go back through the simulation again and say, okay, what happens if time's incremented a little bit? Then you increase delta t, you go back through it, you're in a time loop. It's called the outer time loop that drives the simulation. All dynamic simulations are done that way. Well, so is ours. So is World of Warcraft, so is The Sims. They all work that way. As time is stepped through, characters change and do things, and motion happens. Let's see. We could talk about past, present, and future, now that we understand time. And by the way, time is local to each reality frame. So this, our reality frame, this virtual reality that we're in, has its own clock, its own fundamental time. Other reality frames have their own time. Well, what would be another reality frame? Well, your dream frame. That's a different reality frame. Okay, and you notice something about reality frames. When you're in this reality frame, this seems physical, doesn't it? When you're in your dream frame, that seems physical, and this one isn't. When you're in this frame, this seems physical, and that one isn't. Well, there is no such thing really as physical and non-physical. It's all just a matter of the observer. It's a perspective. There's nothing fundamental about physical and non-physical. Things appear to be physical when your perspective is in that reality frame. And everything else appears to be non-physical. That's taking the theory of relativity one more step. Instead of there is no standard inertial frame, like Einstein said in relativity, there is no fundamental reality frame. They're all just relative to the observer. I just thought I'd toss that in. Databases. There's 3 databases. Actually, there's just 2, but I'm going to make it 3. I'm going to break one into 2 pieces because it's easier to understand that way. First is the future probable reality. So, okay, here we are in a delta t, computed our reality. Now, we can guess what's going to happen the next delta t before it actually happens. Okay, we just extrapolate what's going on. Now, these delta t's are very small. Okay, they're like 10 to the minus 44 seconds. Very small. That's a nanosecond. Okay, very small. Much, much smaller than we can measure by about 35 orders of magnitude. Okay, so to us that seems instantaneous, but it's not really instantaneous. Okay, so these things are very, very tiny. And that's just our clock. So what we have to do is try to guess what's going to happen the next 10 to the minus 44th second from now. Well, that's not too hard, right? Because when you guess real short in, it's kind of easy to make that guess. But then we can say, well, let's assume that we guess right. Then using that as truth, let's guess the next one. And we assume that that one's right. Let's guess the next one. We can keep doing that and work it out just as far as we want to. But of course, our accuracy gets rattier and rattier the further we go out because we've got this whole stacked list of assumptions, each one being that the last one was right. Okay, but we can do that. And that's called the future probable database. Now, there's a rock rolling downhill, then the next delta t, what's it going to be? Well, it's going to roll a little further, right? So that's easy. All the stuff is easy to calculate. What about the people and their choices? Well, that's not that hard either, because if this is a virtual reality, you are a collection of data, rules, memory, the things we said that was consciousness. Your consciousness. That's what you are. You're a piece of consciousness getting a data stream. That data stream you interpret as this reality. Okay, so everything happens in the present. Free will happens in the present. So you are being modeled because every thought you had, every idea, every feeling, every tiny thing that makes you up as consciousness is data. It's all saved. And there's a model of you there, basically, that can project to the next delta t. And it's a pretty good model because it's got all the data of everything you felt, said, done, thought of. So it's not that hard to project you either, but that doesn't mean it's always right. You have free will. You can always do something different. And when you do, the system just has to make that adjustment and run it back up through the calculations whenever that happens. But it doesn't happen that often. Okay, everything then, we make all our choices in the present. After the present, what was the probable future then flows into the past. Now, in this probable future database is everything that possibly could happen and the probability that it would happen. Okay, associated with probabilities. So then after the present, we make our choices. And our choices, like I say, may or may not be what was predicted, but we make our choices. And then everything that we did, the choices we made, become our history thread. And everything that we didn't choose, in other words, everything we could have done but didn't, becomes the non-actualized history. This is really just one database, this one history database, but we're breaking it into 2. Our actual history and all the things we did and all the things we could have done but didn't. Okay, so now we have these databases. All right, and next you'll see how these databases are important. All right, now I'm going to talk just a little bit about what all this means in the larger reality. Okay, you are consciousness, your reality is data. How do you communicate to another consciousness? You have to move data. Okay, now how do you make up data? You have to put that data in terms of symbols or metaphors. And metaphors really are symbols, just of a different kind. So you have to put it in terms of metaphors and symbols. Some thought, something that you have. You make it in a metaphor and symbol, and you pass that out there to another. And what does that other do with it? They take the data, that's all they can get is the data you send, and they have to interpret that data in terms of their own symbols and metaphors based on their experience. You can send it out in terms of your experience. You cannot put it in terms of metaphors you've never experienced because you don't have those metaphors. They can't interpret it except by the metaphors in their experience. So that's the nature of communication. Okay, you can see that tells us why there's so much miscommunication. Okay, that's the way it has to happen. Now, so experience within various reality frames are defined and limited by your fears and beliefs because the way you interpret that data you get has to do with what's in your experience base. That's all of your knowledge. That's all of your lack of knowledge. That's all of your fears. That's all of your ego. That's all of your love. Everything that you are is pulls together to give a best pattern match for that data you receive. But it's a shadow, it's an expression of you, how you interpret that data. And from the sender's viewpoint, it's expression of them, of the data that they send. You can never share an experience with anyone directly. Experience is unshareable. It's private and it's personal. You can describe that experience in terms of symbols and metaphors, and you can share the symbols and metaphors, but you can't share the experience. See, it's unshareable. It's yours. Okay, so here's how some of this stuff comes out. I'm going to use Bob's first book because everybody here certainly has read that probably more than once, and most people out there in the larger world have read it as well. It's a very popular book. Do you remember once when Bob was out of body and he was trying to come back and he ran into a wall? Yeah, he got into this wall. Well, what is that wall? Some of you may have had experiences similar to that wall. They run into that wall. That wall is just a metaphor. It was Bob's metaphor for a fear of not being able to get back. Okay, that's what it was. He gets the data, he interprets the data, his interpretation was the wall. That was the fear. When you're in that out-of-body state, you often manifest your fears. Now, I'm not talking about an intellectual fear. I'm talking about a fear that's down at the blood and bone and sinew level, not one that's up in your mind. But we have those fears. We have a lot of fears that we don't even know we have. They come with our culture. They come with just existence on this planet. We learn it just by breathing and interacting with other people. Remember, he stuck his hand through a hole and got a hook in it. Okay, that was the fear of the thing that can get you, right? The boogeyman under the bed when you're a child. Okay, that was another metaphor. How about people doing NDEs, near-death experiences? A lot of them go through tunnels, right? They get in a tunnel and they go through a tunnel and there's light at the end of that tunnel and they open up and they're in a different reality frame. Why do they go through tunnels? I assure you it's not because consciousness system is full of tunnels. That's not it. So why do they go through tunnels? They go through tunnels because they have a belief that you can't get somewhere without going. Right? Why do people fly in the outer body? Because they have a belief that they can't get somewhere, they can't get from A to B unless they move. Otherwise, if they don't move, there's still a day. Well, that's a belief. That's not true. When you're out of body, you teleport. You want to go someplace, you just change the data stream, hook into a different data stream, and you're there. You don't need to travel, but we have that belief. That's why we need tunnels. Okay, so these are just metaphors. Flying is just a metaphor. What about the great white light? People get into the larger conscious system and they often will find this. They run into this being. It's a great light, white being, and they feel the love. They feel the connectedness. It is so wonderful. They just one with all, and they just rest in that beautiful spot for a moment. Well, yes, they have tapped into the larger consciousness system because that's what it is. A system going toward lower entropy, toward love, and it turns into this white light. They see, right now, where are your eyes when you're out of body, right? They're back in your body. You don't actually have eyes. You don't actually have ears, but you see and hear things out there. How's that? It's because you interpret in terms of metaphors of your senses because that's the only thing you know. If you don't interpret it in terms of your sense metaphors, you can't think about it, much less talk to somebody else about it. It's not yours to deal with. So everything, the data you get has to be converted into some metaphor applied to your sensory data because that's all you know. Okay? So, and why a white light? Well, why do good cowboys wear white hats? You know, that's part of the archetype. You know, it's a social belief in our system. Besides, a black light would be hard to see, wouldn't it? What about the silver cord? If you remember those people going out of body, it wasn't called out of body in those days. Bob was the one that coined the word "ooh" because he wanted to get away from all the junk that went with the out of body, the astral projection. But everybody did astral projection. You know, Fox, Muldoon, and Carrington. If you've read all those old books, everybody that went out of body had a silver cord. They needed that silver cord because that was their lifeline. Because their belief was that the spirit and the body had to be a united whole, and if the body lost the spirit, the body would die and go away, and if the spirit lost the body, it would, you know, wander forever and be lost, and so on. So they had to be connected. That was a fear. That was a need. So they connected it with a silver cord. Okay, well, where are the silver cords now? Bob didn't talk about any silver cords. You know, nobody sees silver cords anymore. Well, they're just not needed anymore because we don't have the same belief system. For those people, that was just like the air hose going down to the diver, right? It was necessary. If they lost that cord, how could they get back? You know, it's like the breadcrumbs, you know, from Hansel and Gretel. You know, that was their way back, and that was their lifeline because that was the belief that they needed it. Okay, so silver cords go away. Specific beings, angels, saints, relatives. You know, you see Uncle Fred, right? Uncle Fred, you know, he's been dead 10 years, and you go out and see Uncle Fred, and there he is. He's in that same plaid shirt, you know, with that same straw hat, you know, and a corncob pipe, just the way you remember him, that same smile on his face, and you talk with Uncle Fred. Do you think Uncle Fred's been 10 years without a change of shirt? Yeah. You know, we dress those people based on our own knowledge. That's because that data that says Uncle Fred to us, then that's our interpretation. That's our metaphor we put on it. Well, what about beings in general? When we have a conversation, we get data that we interpret as conversation, then we turn it into a being because we have no conception of getting data from a rock, right? It has to be another being if it's talking to us. And if it's a being, of course, we kind of make it look like it's got a head on top and shoulders and arms. That we kind of make it look like us because that's our concept of being. So those beings that you see out there, that's your metaphor. The way you dress them is your metaphor, okay? And those people that we don't know how to dress, I mean, we know how to dress Uncle Fred, but we don't know how to dress a lot of those people because we don't really know who they are, where they're from. What do? Put a robe on them. They all wear robes. Yeah. Robes are high fashion in the non-physical. Everybody there wears robes. I mean, yeah. You ever been in the non-physical and seen somebody naked? No, never, because we have beliefs generally that make us use those metaphors. Okay, let's do a couple of more metaphors. Now those are easy. What about when we heal? What do? We envision the bad stuff needs to be healed as like a dark mass of some sort, right? And we put white energy on it. We project white light to it until we burn all that dark stuff away. It's the way a lot of us heal. Well, that black thing is just a metaphor, right? That white light is just a metaphor. There is no light. We send somebody energy. Oh, and they feel better. There is no such thing as energy. This is a virtual simulation. That's a metaphor. Energy is our metaphor for something that makes a difference, for something that has power and that can produce an action. Just a metaphor. There's only one active ingredient. Consciousness. Conscious intent is the only active ingredient. That beam of white light is a metaphor. What about the Hindus? The Hindus have chakras, right? They have 7 chakras and they place them in different places of the body. The chakras are just metaphors. Okay. Now, when I say just metaphor, you might get the idea that metaphors really aren't all that important. No, metaphors are good. We need those. That's how we communicate. We can't communicate without them. It's not that a metaphor, just a metaphor, means it's not really real. We need metaphors. That's how we break things into pieces. That's why I told you there were 2 databases instead of 1. It's easier for you to see it that way. So we take the data, We break it into things that's easier for us to see, that makes sense to us. We give those various pieces properties, right? And then we can talk about it, and then we can have conversations. So we work up these models. They're all models, and they're just models. Okay, so you're beginning to see that I am stepping all over your beliefs here. So light's a metaphor. Energy's a metaphor. All of these things are just metaphor. All right. Now, so the nature of a virtual reality. This will be another big step. If you think I'm leading you down a rabbit hole now, this one's a big step for you to take, but it's the way it is. So I'll tell you the way it is. If you remember what your kid was playing, and I'm going to use World of Warcraft and Sims because those are the only two I know. In the World of Warcraft and Sims, do the people who make those games, do the programmers who make those games have to render, they render the characters, right? They render the images. Do they have to render oxygen for the images to breathe? Well, you're thinking, oh, that's ridiculous. Of course they don't have to render oxygen for the characters to breathe. They're not real, like us. They're just made up in a computer. They're just virtual characters. Well, if one of those World of Warcraft characters falls in a lake or falls in a river, or if in the Sims, they get in a swimming pool and there's no way to get out, there's no ladder, what happens to them? They drown. Why do they drown? Because there's not enough oxygen underwater for them to breathe. That's why they drown. You don't have to simulate or render the details. You only have to render the effects. And that's true in this reality as well. There's no reason at all to render any oxygen in this room. No reason whatsoever to render oxygen in this room. Okay? This is a probabilistic reality, a statistical reality. Here's the measurement. I'm still here. Then the measurement said that there's oxygen in the room. That's because when the measurement was taken, you go to the probability, you go to the statistical distribution, and you make a sample. Is it probable that there's oxygen in this room? Well, look at the rule set. The rule set says, well, there's trees around, there's still there's plankton in the ocean, all these things that make oxygen. Yes, it would be probable that there'd be oxygen in this room. Well, if it's probable that there's going to be oxygen in this room, then we carry on. It keeps rendering us. We cut down all the trees, kill all the plankton, then it's not probable that there's going to be oxygen here. We all fall over, you see? So it's a probability-based reality. You don't render anything that you don't have to. That's wasted cycles. Okay, so right now, you're all looking to the front of the room. In your minds, there's no data in your data stream that's rendering the back wall. None. Back wall doesn't exist for you now because it's not in your data stream, because you're not looking at it. You turn around and look at the back wall, this is not rendered for you. You only get the data you need when you need it. It would be wasteful of computer cycles to render anything that wasn't needed. In those video games, your little video character turns around a corner, and in the background you see the trees spring up and the mountains jump up. That's because their server isn't very fast. Well, this is working on a cycle of 10 to the minus 44 seconds. Let me tell you, it's fast. You don't notice those kinds of things here. Okay, now I'm going to, here's one important thing, that middle bullet there. When something is rendered, it must be consistent both historically with existing data and causally with the rule set. Those are the only two rules. This is a statistical reality. And what it renders is based on those two rules. It has to be consistent. That's why when that particle went through was detected at that slit, it couldn't do anything after it was brought into the reality as a particle except go in a straight line like particles do. Okay? Because once it's rendered here, it's here and it has to abide by the rule set. And the rule set says that particles travel in a straight line unless acted on by some other force. So as soon as the probability collapses to a physical value, then you have to abide by the history. You can't have history jumping around. It has to be consistent, and you have to abide by the rule set. Well, it's the same with us. And you're going to see this is going to explain a whole lot of things that are right now unexplainable. Okay, now I'm going to solve one deep mystery that we've all pondered over and probably laughed at, and we probably wrote it down as a semantics issue, but you're now going to get the definitive answer to it. If a tree falls in the woods and nobody's there to hear it, does it make a sound? Well, here's the answer to that. There is no tree. There is no woods. There's no listener. They're all virtual, statistical, and probabilistic. Okay, now how does that work? So a man walks into a woods. Okay, this is a virtual man, walks into a virtual woods, and what's rendered for him? What's rendered for him at that instant, because it's probable, because of all the history and the background and so on, that there's a dead tree standing there. And it's kind of wobbly, but it's still standing. And that's what gets rendered to him. Okay, let's say that this is the first time he's been in that woods, but he sees that dead tree. Now he goes away and he comes back 5 years later and he walks into the woods, and what's rendered for him? A tree lying on the ground. Why? Because that's probable. Because 5 years later, probability would say, given the rule set, that because of winds and storms and the natural things that would happen over 5 years, that tree would fall over. So you see the tree was standing, then it was laying on the ground, but it didn't have to fall. It was just rendered to him standing, and it was rendered to him laying on the ground, because that's when the measurement was made. And when the measurement's made, you go to the reality is just a probability distribution, just like those particles. Hey, these particles make up all this reality, don't they? I mean, everything here is made up from those little particles. And just because it happened with photons, it also happens with electrons and protons and atoms. All massy things are just probability distributions until they're measured and come into this reality frame. Okay, that's a fact of physics. So it gets rendered based on the probability. So we find out that this whole concept that is said just to be only used for the very tiny little things in quantum mechanics. Only on a subatomic scale does this hold. It doesn't. It holds in everyday life. Our whole life is governed by the same principle. Doesn't that seem odd to you that there's this general physical principle and it only holds for little things? No, it holds for everything. It's one principle. Okay, so let's go on to the next one. I'm seeing Shirley eyeing that big hook. I need to move on before she gets after me. Okay, you are consciousness experiencing a virtual reality generated by consciousness. So you see, you're part of the creation as well as part of the, as well as the experiencer. You're the creator and the experiencer both. Okay, the system's designed to facilitate its own evolution by facilitating our evolution, and gives us a PMR where experience and feedback, facilitates that. Now, consciousness intent changes the probabilities. So we talked about that future probable database. Your consciousness can change the future, can change those probabilities, because your consciousness, the system's consciousness, the reality is just data. Okay, now how does that work? Well, you've heard of the power of positive thinking, right? 1950-something, Norman Vincent Peale wrote The Power of Positive Thinking. What everybody knows, that's obvious, right? If you think positive things tend to happen. If you're a very negative person and you're just grouse about how awful life is, you end up having a lot of awful things you have to deal with. That's the power of positive thinking, a very obvious thing. I know people who create parking spaces for themselves because when they leave their home going to a congested area, they'll, in their mind, visualize a parking space just opening up just as they get there, because if it opens up too soon, somebody else will snag it, right? So they have one open up just in time for them, and they work on that. And if they apply their mind to that, they find that about 80% of the time, they get a parking space. If they don't do it, about 80% of the time, they don't get a parking space. People hail taxi cabs in the same way that live in cities. You have to visualize that taxi cab. You have to see it. You have to apply your mind to it, and you can make those things happen for you. Right? That's kind of, we do that sort of thing a lot. I have another guy, he says that he walks in a grocery store now. He never gets a cart as he goes in. He materializes a cart inside the grocery store. So he can just walk through the doors, and there's one just sitting on the floor with nothing in it. And he picks that up, and he says that works about 80% of the time when he does it. So these are little games that you can, that you can play to see how that works. Okay, well, what about prayer? Okay, prayer works. Why? Because you have people focusing their intent. That intent modifies the probabilities of the way things happen. What about healing? That's how healing works. You heal not because that little black thing, disappears with that, that imaginary black thing, or that symbol black thing with that symbol light. All those symbols are doing, those are just tools and metaphors that help you focus your intent. It's your intent that changes the probabilities. Consciousness is the only active ingredient going on here. The rest of it is just tools. All right. What about the placebo effect? Very widely known effect in medicine, right? You give people a pill that's got sawdust in it or something, and most people say sugar, but sugar's so bad for you, I can't say that. So it gives you a pill with sawdust in it or just cellulose, And they take that pill and they're told the same thing that people are told to take the medicine. They're told, this is a wonderful new pill, we've just invented it, it's great, it's going to cure your disease. They take that pill and about 30% of them makes them better. And it's not that it makes them feel better or just think they're better, it actually heals them, makes them better. How are they healed? How does the placebo effect work? It works because they now have a positive intent, and that positive intent modifies the probabilities. Okay? And once you modify those probabilities, you're modifying what you're going to find when you take that measurement, right? You're modifying that probability function. You're modifying the probability wave function, if you will. Okay, now that takes us to one that's kind of been rampant in the last some years. What about the law of attraction, right? That law of attraction, that's the same sort of thing, right? You use your mind and your intent to program, they say the universe, but it's really the larger conscious system, to give you what you want. Okay, well, that works in that you use that intent, you can modify the probabilities, sure enough. But beware, you have a system that is generated to help you evolve and has this feedback in it so that your intent does modify future probabilities. Therefore, it modifies your future choices that you make, future measurements, the results of future measurements. But at the same time, this system is here to help us evolve. That means lowering your entropy by getting rid of ego, getting rid of fear, becoming love. So now take a system that is evolved to respond to your positive intent and to help you drop your ego. You see, you're asking, if you use this law of attraction to aggrandize your ego, to get stuff because you want it, because it makes you big and important and so on, then you're asking a system to use itself against itself. What's probably going to happen is that you may even get what you ask for, but you're also going to get a lesson that comes with it that will help you decrease that ego. And here's an example. There was a fellow who wanted $100,000. If his life would be perfect if he had $100,000, so he spent his time focused on that $100,000. He saw pictures of a man walking down a corridor in a suit, handing him a check for $100,000. He worked on it and worked on it and worked on it. About 4 months later, his mother and father, his brother and his sister and all their children all died in an automobile collision. And he was the sole heir, and he got $100,000, and that man walked down that aisle and handed it to him just like he saw it. Well, now there's a lesson in ego. So if you're going to ask a system to work against itself, you better be careful, not necessarily what you ask, but why you ask it. It needs to be for the right reasons. So yes, law of attraction works, but don't ask it to work with your ego. All right, synchronicity. How does that work? Okay, we talk about synchronicity. Jim mentioned that. I'll explain to you how that works. A system only has to compute the probability of the next thing happening according to history and a rule set. Remember, those are the two things. Okay. A weak history provides for multiple solutions. Whenever you have uncertainty, the system only has to abide by those two rules. So if any one of those rules is loose, then the system has leeway, right, to the solution that it can provide for you. All right, so let's look at an example. You go away for 2 weeks, you come back, you've been in airports, airplanes all day long, your throat's kind of sore, you'd like a nice carbonated beverage, so you open up your refrigerator door, and there's no beer in the refrigerator. And you know that there was at least 3 or 4 beer in that refrigerator when you left. And then you think, what happened to the beer? And you go, oh, I bet the guy that comes in that gives the dog, water and food, he's been drinking my beer, I bet. Well, perhaps not. You see, unless you took a picture of what was inside that refrigerator, it's not really a part of the record. It's just your memory. And, everybody knows memory plays tricks on you, right? Memory's not that good. So when it comes times to open that door, what are you doing? You're making a measurement. When you open that door, you're making a measurement of what's inside that refrigerator. Well, if you had taken a picture of what was inside there and you could see that there were 4 bottles of beer sitting in there, then the probability distribution for that 4 bottles of beer would be a real sharp high delta function, a real sharp peak of probability, because you've got the record. It's in the system. So historical, staying within what historic demands would make that beer have to be there just like the picture. Unless, of course, your guy's stealing your beer, but then you'd know for sure. Anyway, if it is just you and your memory, instead of that sharp probability, you have this big kind of broad probability, because there may be 4, there may be 3, there may be 2, there may not be any. And when it takes that sample out of that probability function, it might just get 0, or it might get 6, or it might get 3. Okay? So you open that door, you make a measurement, the wave function collapses to a physical state, and there's a certain number of beer in that refrigerator, and that's what you get. Now, because the system can do multiple solutions, it can manipulate that to nudge you, and that's where synchronicity comes from. That's also where all these anomalous things comes on. How many have put your glasses or your keys or something someplace? I left them on my desk. You come back 4 hours later or next day, and they're not on your desk. And you find them, in your bedroom or someplace, and you knew you didn't leave them there. How many times do things like that happen to you? Well, these anomalies aren't necessarily because you're just getting old and can't remember where you left things. Sometimes that's just the system. The system may not know exactly where you left it because there's no data, because the probability function is broad, and when you make the measurement, it's just not there. So you live in a very flaky reality, you see. But it'll only do that when there's enough uncertainty that there is no violation of either the rule set or of the consistency of the history. Okay, and we'll see how this plays out in the next slide or two. Okay, so what about the synchronicity? So you look in the refrigerator and there just happens to be no beer because the system wants to nudge you a little bit. So you go get in your car, you drive down to the neighbor grocery store, and you're driving in the parking lot, and you drive right by this empty space, and you say, okay, you drive by it, and you go to back in it. You start to back up, and just about the time you expect you'll be entering a space, you turn around and look, and just as you look, crunch, you hit a car. And you look back there and say, where did that car come from? Right? Where did that come from? It wasn't there, I just looked. And then you think, somebody, some jerk just pulled into that space just as I was backing into it. So you look again, and there's nobody in the car. You say, boy, they must have been fast. So you get out, and you walk around to the car, and you look, and you see, well, there's really no damage. You're going very, very, very slow, and there's no damage. And about that time, you look up, and here's somebody coming out of the store with 2 bags of groceries. Obviously, had been in there a while, and that's their car. So they look out, and you both look at the thing and say, well, there isn't any damage. And then what happens? That person turns out to be your soulmate. You get married. That person turns out to offer you a job. That person turns out to invite you to their meditation class, and it changes your life. That person, and so on, right? This is synchronicity. Things just happened. And no beer in the refrigerator, went to the grocery store, went to the car that wasn't supposed to be there, ran into the person that changed your life, or was very meaningful, or turned you on to a particular book, or whatever it is. That's how the system works synchronicity. It's that uncertainty gives it the ability to manipulate you and nudge you. And it can do that as long as it doesn't violate those 2 principles. It's a statistical reality. We don't live in a objective reality. If I had time, I could explain to you why objectivity is only an approximation. We live in a statistical, probabilistic reality. Quantum mechanics tells us that. We just don't believe it because we don't know what to do with it. But that's the way our reality is. All right, next. Now we're going to use this knowledge to solve some problems. Okay, the false appearance of backward causality. Now this isn't the little experiment I'm going to give you follows what actually happened, but isn't what actually happened, because I'm just giving you a kind of caricature of it that makes it easy to understand. Okay, imagine 20,000 hospital records. These hospital records go back, say, over 2 decades. 2 decades of people coming out of a hospital. You're going to take those 20,000 records, you're going to break them into 20 groups of 1,000, randomly separate them into 20 groups of 1,000. Then each group of 1,000 you're going to randomly break into 2 groups of 500. One of those groups of 500 is a control group. The other group, you're going to use your intent to improve the health of those people that are in that one group of 500. Okay, now this was done, first one that I know of that was done in Israel, and I think it was a group of rabbis and others who prayed for these people or otherwise used their intent for their good health. Well, what they found out was that group that they had prayed for and used their intent to make them healthier, they had statistically significantly lower hospital stays, shorter hospital stays than did the control group. Statistically significant. Well, that means that, there was only probably a 10% or less probability that that actually could happen that way. Well, that's not that amazing. Things that are only 10% probability happen every day. But then they did the same with the next group, and the next group, and the next group, and eventually they had all 20 groups. Every one of them that they had prayed for and used their intent on had shorter hospital stays than the control group, the other 500. All right, now the first one was interesting, but not miraculous. 20 in a row, now you're talking about 1 in a million. That's like flipping a coin 20 times and getting heads every time. Hard to do by accident. Okay, so this is the conclusion they came to, is that somehow they were affecting the health of these people in the past, because this data was old. This wasn't current data. This was old data. That's called reverse causality. This experiment is done a lot of different ways. It's been done over and over. It's been done at Princeton. It's been done lots of places, not necessarily with patients. It's done with radioactive isotope, where they take a radioactive isotope that's decaying. They take 2 Geiger counters. Each Geiger counter should over time get roughly the same number of counts, because when it decays in any particular direction. Then they take this data, and years later they'll have people bias the results such that, say, the Geiger counter on the right gets significantly more counts than the one on the left. They have a little Paralab, they have a little robot, and that robot is given a random motion in the 4 directions. So they put it down in the middle of a big circular table, and they let it just wander around. And they can let it wander around for days, and it never leaves, maybe about a square foot box where it just wanders around at the center of the table, because it's random motion. So you get as much going one direction as the other, and it doesn't go anywhere. The person applies their intent to it, that little robot walks across the table and falls off the edge. Now, these are experiments that have literally been hundreds of times under immaculate protocol and scientific inspection. So this is a fact that happens. Okay, why does it happen? Well, obviously, they're modifying reality, right? But are they affecting these patients 20 years ago? Of course not. What are they measuring? They're measuring the data. They're measuring that data of those hospital patients, those hospital stays is what they're measuring. And they're biasing that data because that data hasn't been brought into this reality yet. Nobody's looked at that data. So that data is still in the future. I mean, the statistical results of that data are still in the future. Nobody's ever calculated them. And because it's still in the future, it's just probability, like everything else that's in the future. It only exists in probability. And like everything that exists in probability, conscious intent can modify the probability. So that's how they do that. Now, let's say that somebody takes that data, and before it's given to the rabbis, they do a statistical analysis of what's in both pieces, this 500 and that 500, right? They do the statistical analysis, and they know exactly what those average hospital stays are in both groups. They give it to the rabbis to work on, and they worked on it, and they worked on it, and of course the rabbis didn't know that this had been done. Guess what? They couldn't do it. They couldn't bias it one bit. It just didn't work. Why? Once the data's here, there's historical precedence. It has to stay here. You can't change it. That would be against the rule set. It wouldn't be coherent history. All right, now what if they just, before they gave it to the rabbis, they just looked at the statistics for the whole set of 1,000, but not the 2 individual groups of 500, and then give it to the rabbis? Would the rabbis be able to do it? Yes, but guess what else would happen? As much as the group that they prayed for went to shorter hospital stays, the other group would have to go an equal amount to longer hospital stays, because they have a constraint now that they didn't have before. I don't know that they've ever done that experiment, but if they did, that's the way it would have to come out, because that's the way this works. Okay, so if you just looked at the whole 20,000 and did statistics on that, then yes, you could bias things, but again, now you have a constraint, and you have to meet that constraint because now that data is in this reality frame. All right, let's take another example. Let's say that they took this data and they did measure all the groups of 500, and they know exactly what the statistics were on all of them, and they put that in a drawer, and that building caught fire, and the data went away. All right, now they can pull that data back out of another computer someplace where it's still never, the statistics haven't been done in the computer. They just were done once, and no record was kept except what was in that drawer. And the guy who did it, well, geez, there was 20 groups, and that was there was 40 different groups of 500, and he doesn't remember what it was. Okay, could the rabbis modify that data now? Yes, they could. Because even though that data was here, it's not here anymore. It's back in the future, right? It's back in the future because now it wouldn't violate any rules however that data came out, because we don't know how it's going to come out anymore. So you see, things can come and things can go. What matters is just those two rules: historical consistency and abiding by the rule set. This is a probabilistic reality that you live in. How does Bill Tiller make the pH go up in his water? With intent. Well, how does he do that? When you look at the pH of water, it's not a straight line at 7. pH of water, if you look at it down at the microscopic level, where you can see variations to 20 decimal places, the pH is doing this, with time, all the time. It's jumping around. There's little H pluses and OH minuses that are combining and recombining, and all that stuff is going on. It's a dynamic situation. Well, there's uncertainty in there. And where there's uncertainty, you can modify the future. So with an applied intent, you can say that in that uncertainty band of pH, even down at the 0.01 level or wherever that uncertainty is, it doesn't matter. You can modify so that when it makes the choice, so when you make the measurement, you stick that meter in, you can bias it up a little bit within the uncertainty, not beyond the uncertainty. You can't at one leap. Those people couldn't have made every patient on their 500, get out of the hospital, in an hour. They couldn't do that. They can only move it within the uncertainty that's there. Okay, so you can move that pH up within the uncertainty of where it might be at any instant, and then you move it up a little more from that one, move it up a little more, and just like you walk that robot off the table, you can walk that pH up in level, or you can walk it down. The mind does these things. So that's how that experiment works. Now the little robot, what you're doing there is when it's going to pick a random number, from our viewpoint, we don't know what that random number is. It could be anywhere from here to here. Well, that's an unknown. Because it's unknown, we can bias it. We can make it pick it a little to the high side, a little to the low side. And enough, a little to the high sides all in a row, the robot walks off the table and falls. Okay? So that's how all those experiments work. All right, now, I'm going to talk about virtual reality a minute. Those green boxes are little volumes of volume. Okay, this is a virtual reality. To make any virtual reality, the main thing you have to understand is how much computing resources you're going to need for that virtual reality. So if you were going to build a World of Warcraft, that'd be your first calculation. How much resources do you need? Well, that's spec'd by two things. One, by how big's a pixel? Okay, so if we look at your computer screen, a pixel is just a little box that has a value that tells the color and the intensity. Okay, now if you have a whole lot of pixels, a very dense, high density of pixels, you get very high resolution. But it's also, every pixel is data that you have to provide. So the more pixels, the more data it takes. Okay, now your second thing is frame rate. How often do you have to update those pixels? You got a lot of pixels, you have to update them for a whole lot. Then it takes a lot of throughput and a lot of data. That's how you spec a virtual reality. All right, our virtual realities are spec'd the same way. Okay, here are these pixels. These pixels of volume, because we're in a three-dimensional game, not a two-dimensional game. Okay, a 3D pixel is one quantum of volume. The frame rate, that's that delta t. The simulation, the outer loop time goes around delta t. That's a quantum of time for the simulation. All right, now, the quantum of volume, they have to be constant. The reason they have to be constant is the same reason why the pixels on your screen have to be all the same size. Let's say you had a computer screen and you had a whole bunch of little tiny pixels down here, and then in the middle you had pixels that were like a square inch apiece, and then over here you had some that were in between and are all over. Well, what would something moving across your screen look like? It would look like you were looking at a funhouse mirror, right? It would be terribly distorted. It would come and go, and it wouldn't be a smooth kind of motion anymore. Well, that's the same thing. If you change those pixels of volume weren't constant, a ruler over here would be let's say would be 1 foot, but you move it over here, it may be bigger because the pixels aren't all the same size. So you have to have constant there. It's the same with the time. If the delta t wasn't constant, then it'd be the same way as if your computer screen wasn't updated at a constant rate of 240 or 60 hertz. Your motion would be jerky. Suddenly you go fast, it'd be like jumping back and forth between slow motion and fast motion. Stuff would be jittery and jumping all over. Well, you can't have that. So if these two things are constant, and they have to be in order to produce this homogeneous isotropic reality, which we need to be functional, right? That's required. Otherwise, we have a funhouse reality, and you don't have feedback. It's not a good schoolroom where your children can't depend on what's going to happen next. Sometimes the teacher's there, sometimes they're not. Their books come and go. You can't have that kind of schoolroom. It has to be buttoned down and consistent. So you need this homogeneous isotropic reality to be functional. That's a constant. That's a constant. Then C is a constant. And this cube root of delta V is just a distance, right? That's a volume. Take cube root of it, you get a distance. Well, what does this mean? What this means, that C is the speed of light. So these cells, something that moves through this reality has to go from this cell to this cell to this cell to this cell, because otherwise it would be teleporting, right? If it didn't move through contiguous cells, it would be here, and the next minute it would be someplace else. That doesn't fly in our nice reality. That wouldn't make a good schoolhouse either, with things coming and going and disappearing all the time. So because we need this homogeneous isotropic reality, that V must be a constant, delta T must be a constant, and C is a constant, and that constant C is how fast things can move through this reality frame. Delta T, the very next delta T, as far as it can go, is the next cell. Next delta T, as far as it can go, is the next cell, and so on. So that puts the upper limit of the speed of light as a constant. And that's because, one, we need this isotropic reality. Our calculus wouldn't work. None of our rule sets would work if we had a funhouse reality. And what that tells you is that relativity theory is a logical consequence of C being constant. C being constant is a logical consequence of reality being digital and virtual. The magnitude of C represents a constant that specifies the demands placed upon the virtual reality rendering engine. Okay, it's just, that's what specs how much crunch power you need to produce this reality frame. And that's constant. All right, summary and results. Let's just run through a couple of quick results here. Okay, here's some deep sighs. So I'm getting close to the end, guys. Hang on, just a little bit more. I don't see a hook, so we're all right for a few more minutes. Okay, summary. Modeling consciousness as a self-modifying digital information system that evolves towards states of lower entropy. That's our model. Okay, physical reality is a virtual reality, a subset of the larger consciousness system, designed to help budding individuated units of consciousness, that's you, evolve by lowering their entropy through experience and interaction. Results. Okay, results are that physics and metaphysics become parts of one logical theory and are thus unified. Love and spirituality are both defined in terms of entropy. Normal and paranormal are unified as just one thing. It's all normal. It's just the way our reality works. We have derived a fundamental purpose of existence in general and of our existence in particular, and that is to evolve toward lower entropy states. Result is that time, relativity, and quantum mechanics have been derived from one overarching fundamental theory with just two assumptions. There's only two assumptions in this model, and that's that consciousness exists and that evolution exists. The measurement problem's been solved, the invariant velocity of light problem's been solved, and we have solved Einstein's little toe. Okay, we can now explain both of those. A lot of other things have been solved too. We'll get to some of those later. Additional results, lowering entropy increases the energy, power, information available to an evolving entity. Okay, think of some people that you know of who have evolved toward being love. In other words, they're more evolved. Who might come to your mind? Mahatma Gandhi, Buddha, Martin Luther King, Mother Teresa, right. These are all people who have evolved toward. Now make a list of the people who really are powerful, who have made humongous effects on their cultures, on their societies, on other people. It's the same list of people, isn't it? You see, lowering your entropy gives you more power. Remember that bottle of gasoline? We showed that. You lower your entropy, your power increases. Okay, love is defined as the fundamental expression of low entropy consciousness. The larger consciousness system is a aware evolving system. It's real, therefore finite. We are individuated units of consciousness, chips off the old block, one with all that is. We're all netted. Every consciousness, we're all a part of this whole thing, right? And we're all netted. And we're not a little individuated part sitting off by ourselves. We're just a part of the whole consciousness system. You know, a good example of that is you have a Word document. Where do you think your Word document is on your hard drive? You think it's a little bundle of 1 and 0, some corner of your hard drive? No, it's spread all over. Well, that's the way we are. We're spread all over. We're just part of the larger system. Okay, let's see, where was I? All reality frames and everything contained in them are part of the same consciousness system. They're all connected and they all have the same mission, and that is to lower entropy. What's the difference between physical and non-physical reality frame? Only the observer's perspective. Nothing is different. There's nothing fundamental between your dream state and this state. They're just two different points of view. All right, one last point, and that's your video lag. You know, when you do a virtual reality game, the big bugaboo, the big thing that is a problem is video lag. Okay, well, if you're playing World of Warcraft, you can help fix that video lag by speeding up your computer. There's two things it causes. One, it being last in line, and second, being slow. Okay, in the World of Warcraft video game, you're both. You're last in line because the server has to compute first and it sends it out to you. So you're last in line to get the data, and then your video card, your computer, your network is slow. So what can you do there? Well, the only thing you can do there is speed up your video card and your computer and your network, right? You can't change that you're last in line. Now, with consciousness, it's just the opposite. What's slow in this virtual reality? What's slow? We are. It's this physical body. This virtual body has to abide by the rule set. The rule set that evolved us, right? Our whole planet evolved out of this rule set, right? It was the big digital bang. In the computer, you have a bunch of energy, you put it in a tight spot, and you let it evolve, and eventually you end up with our universe, and then you end up with this planet, and then you end up with us. We all evolved under this rule set, so we represent that rule set. You can't change the rule set, so slow is fixed, but you can change whether or not it comes last. So here's what we would do. Before I get to that, I have one other one. You have to understand about little consciousness and big consciousness. Okay, little consciousness, little c consciousness is your intellectual awareness. That's what we call our individual consciousness. What we see and hear, that's our little physical matter consciousness. Big C consciousness is the big consciousness system. It's what you really are. Okay. Now, the big consciousness system computes and makes little c consciousness. You have the data stream in big C consciousness. That data stream is interpreted in big C consciousness, and then it's given to you here as your reality. You then have that interpretation. This is your reality. That's a little c consciousness, your awareness. All right, so how should this system work? And we're going to see, we're going to make a prediction here, and then we'll see how it works. First thing that happens is that reality is probable, right? We have our reality starts in the probable database. The very next thing that happens is your body's going to start to move. Okay, now we haven't got to the present yet. We're still at the probable reality. So before you even make your choice, your body, we're going to put the body in next. We're going to move that body up as high in the sequence of events as possible so we decrease the video lag. We're going to start that body moving before we've even decided what it is the body's going to do. Okay, so moving the body up. Now, the next thing we do then is we get to the present where we make a choice. Now, the body started to move based on what was probable choice we'd make, and if it's wrong, the body's got to stop moving and go back and do something else. If it's right, then the body can keep on moving as we progress with our choices. And then the very last thing that happens is that the big C consciousness computes the little c consciousness, and we have awareness. All right, let's look and see how that plays out. All right, anticipation of future events. What you see in italics is not my words. Those were words that were written by Dr. Craig Hogan. He made a list of, and I quote, unexplainable, repeatable, well-documented scientific experiments. Okay, and we're going to go through those experiments and we'll see how each one of them works so that they no longer will be unexplainable. The first was Dean Radin's study showing the body reacts to a calm or disturbing picture 6 or 7 seconds ahead of time. Now, what he did is he had a computer with a random number generator going on and accessing a library of pictures. So that computer would grab a random number which is associated with a picture, go get the picture and show it to someone. Now the time between when the random number got generated and the picture was shown was probably milliseconds. It doesn't take a computer long to grab a picture and show it. Certainly no more than tenths of seconds. 6 seconds earlier, people would react to the picture. So they were going to show them something horrible. Now they didn't react in their intellect, they reacted subtly in their body. The electrochemical, mechanical processes in the body are what we need to speed up. It's not the mental part, that's fast. It's the this slow, has to abide by the rule set of this physical virtual reality stuff we got to speed up. So they hooked them up to where they could see what glands secreted, what the EEG was doing at fine levels, the little potentials at the muscles and all this sort of stuff. So these people were wired to see what their bodies got, electrochemical processes going on. 6 seconds before the computer chose the picture, they'd start to react to a horrible or to maybe a beautiful picture. And horrible and beautiful things would cause different secretions and different reactions, and they could measure these. Well, how does that happen? Well, obviously, we know probable reality database allows anticipation. Well, what about that random number coming out of that computer? Well, that's a virtual computer, just like we're virtual bodies. The consciousness system's playing all ends of this game. So it knows it isn't really a random number, it's a pseudo-random number. There's an algorithm that produces that random number, and the consciousness system who's generating that computer knows what that is. He knows what picture's coming up. And it knows what picture's coming up as far ahead as it wants to. Okay. There was another one. It wasn't on his list, but it should have been, called the bright shafts potential. That was back in the 80s. And what they found out is they had these subjects, and they'd say, when the bell rings, raise your right hand. Well, they'd find that very fine measurements of the muscle and the brain, that the motion would start about 1.5 seconds before the bell would ring. So the right hand would start to come up about 1 second before the bell would ring. It's called the bright shafts potential. Again, it's measured. It's old hat back in the 80s. This is science, and it's the same reason, right? We start the body first so we avoid the video lag problem. So it seems like it works that way. No, everybody gets this data ahead of time, but you don't get it far enough ahead of time to operate on it, and you don't get it at the intellectual level. Little c consciousness isn't involved in this. This is big C consciousness. All right, reverse causality. We already talked about that. I just want to point out that what he wrote about it, and this is the misperception people have. He says somehow it has an effect on an experimental group of cardiac intensive care patients. It didn't have any effect on the patients. What happened to those patients is what happened to that patient. That's a part of the record. That came into the system. That measurement was already made. What it affected was the data. Okay, the data hadn't been analyzed yet. The problem is that people believe in an objective, deterministic reality, and they think because what the patients did, the data has to reflect it. Just like they believe that what those Geiger counters got, that the data has to reflect it. Okay, the clicks on a Geiger counter recorded at one time can be influenced. The clicks on the Geiger counter weren't influenced. The Geiger counter clicked however it clicked. It was the data describing those clicks that got modified. The actual clicks on the Geiger counter were gone. They're lost. They're not in a record anywhere. The only record is that data. It's still in the future, what the data is, how many clicks were in each one. You can manipulate that because it's in the future. That consciousness can affect machines that use energy, random number generators, random noise generators, telephones, recorders, and all that stuff. It doesn't affect the machine. It just affects the output of the machine. You see, you have to divorce the idea that the output that the machine makes has to be the output of what happened, of what the machine did. Those two aren't necessarily the same. We live in a probable reality. Okay. The last one, I think, it's the last one, is the fact that no one has been able to show that the brain produces consciousness. In fact, when they put remote viewers and other people in the Faraday cages, which takes away all electromagnetic fields and other such things, it doesn't make any difference. They can remote view just as easily in a Faraday cage as they can anyplace else, and it doesn't matter where their target is, whether it's on the other side of the planet or not. They don't see any time lapse. That's because there is time lapse, but the times are very small. Okay, so consciousness is not physical. Of course, you can't isolate it with physical things. It's information. Information's non-physical. All right, this takes us to basically the last chart, the value of a theory. Unfortunately, in the real world, the value of a theory is whether or not it supports current scientific beliefs. But it shouldn't be. We know that the actual value of a theory is whether or not it explains what is known, then it has to explain what is unknown, and that has to be verified by experiment. And here's a whole list of things that are now paradoxical or mysterious that this explains completely. And here's a whole list of things that new information is being predicted. Okay, so we have all of that. I won't going to bore you with all of that. Okay, like how intent changes random distributions. such as Princeton, Frontier Science Labs, how and why backward causality works, why Lao Tzu and the Buddha, what was Lao Tzu and the Buddha talking about, right? We're all one, get rid of the ego, move toward love, compassion. I mean, see, it's all there. It explains all those things. Why C has to be constant and why particles are probability distributions. Well, physicists right now are worried over the interpretation of that. How do you interpret that these particles are probability distributions? There is no interpretation. They're just probability distributions. That's the way reality works. Everything is a probability distribution until the measurement's made. Our whole reality works that way. The purpose of your existence, what's important, what's not, how people can know things that they shouldn't be able to know, all these psi experiments like Radin's experiment, help people know the unknowable, reincarnation, what happens after you die, how personal psi experiences work. Paranormal information, we're all netted, it's all in these databases, past, present, and future. Precognitive dreams, you're just getting things out of the future database. Healing, you're modifying the probabilities. Remote viewing, if it's a remote viewing around in this reality, you're just getting data out of the databases. When you see auras, I've seen auras for probably 30 years. It's just data. You can define that output however you want. You're connecting to the database and getting data. The aura is just a metaphor. It's a visual metaphor for the data. So the failure of science to find consciousness in the brain or to limit the effects of consciousness, well, it's because it's not consciousness. We finally answered Fredkin's big question. He said, other. It's in other, and we don't know what that is. Well, Dr. Fredkin, consciousness is the computer. You see, consciousness is the computer. Okay, now that gets you now to the point that I was at when I first came out to see Bob Monroe all those years ago. When I came out to see Bob Monroe, my thought was, is this guy nuts or what? Well, you have to be thinking that, because unless you have extensive experience within the larger consciousness system, you really have to have that question and that attitude. You have to be skeptical as well as open-minded, okay? Consistency is strong among people who have experienced. You go back and look at Lao Tzu, who started Taoism, and he expressed his understanding of reality. And it's obvious that Lao Tzu understood reality at a very deep level, but the best he could do was write in poetry. Now, my conclusions agree with his conclusions. The difference between my big toe and Lao Tzu's big toe is that his was poetry minus science. It's all logical, and it derives from the ground up, and it explains all the data. So far, we've not found any data or anything that we could not explain this way, and we are looking for things that we cannot explain. Okay, the last thing that I'd like to leave you with is that truth, big truth, cannot be your truth until it's your experience. What you have to do is find out. And if I give you nothing else, I'd like to give you a spark of ambition and interest and gumption to get out there and find out. It's not as hard as you think. That's it. Thank you, ladies and gentlemen.